The abstract factory pattern is the perfect family creator. It belongs to a group of design patterns called the creational patterns, ensuring that families of objects are created and work together seamlessly. Do you dream of building furniture empires or designing car dynasties? The abstract factory pattern turns that dream into reality by helping you create families of perfectly compatible objects. Does everything make sense up to this point? Well, welcome to Do Some Dev. My name is Gene. In just a moment we'll cover the basics and solidify our understanding with the diagram that visually represents the abstract factory pattern. After that we'll consolidate our knowledge even further with an example in Java and an example in Python. And this would be the perfect occasion to hit the like button of this video. It helps content like this flourish on YouTube, and it also makes me happy. Imagine a furniture store that offers distinct furniture styles, like a whimsical section with colorful chairs and tables shaped like animals, and a modern selection with elegant chairs and sleek tables. The abstract factory pattern works similarly. It allows different factories to define the specific objects they create. This guarantees they all work well together within their own family. The abstract factory shines when you need to address one of the following challenges: creating families of related objects and decoupling from concrete product classes. Let's first take a look at families of related objects. These can be furniture elements like chairs and tables, or components of a car like an engine and wheels. This pattern ensures consistency within a product family by guaranteeing that all the objects created through a specific factory belong to each other and are compatible. Now let's look at decoupling from concrete object classes. The abstract factory shines when decoupling your code from concrete product classes. Traditionally, code tightly coupled to specific classes becomes brittle when changes arise. This pattern lets you work with interfaces instead, and by relying on interfaces, your code becomes more flexible. You can easily switch between product families without modifying the consuming code itself. Examples could be Victorian furniture versus modern furniture, or a sports car versus a truck. In summary, the abstract factory pattern promotes several key benefits by addressing common development challenges: maintainability and flexibility. By decoupling code from concrete classes, the pattern allows easier switching between product families and makes the code more adaptable to changes. By ensuring that all objects are created through a specific factory, belonging together and work seamlessly, promoting consistency within a product family becomes possible. Real-world examples for the abstract factory pattern would be cross-platform development, product variants, plugin systems, and database abstraction. The magic happens behind the curtain. Let's see the abstract factory pattern visualized. The first thing we need is the abstract factory. Creating this interface declares a set of methods for creating product objects. It defines a contract for the concrete factories to implement the creation of a family of products. The next ones we need are the abstract products. Creating these interfaces enables to declare methods common to the family of products. They define a contract for concrete product classes to implement. The next one we need are the concrete factories. These are implementations of the abstract factory. They have the responsibility for creating the defined family of products. Now we are ready to create the concrete products. These are implementations of the abstract products. Each concrete product class provides a specific implementation of the methods declared in the corresponding interface. Time to see how the abstract factory pattern looks in Java. The first thing that we need is the abstract factory interface. Here we define a method createProductA that returns an abstract product A, and a method createProductB returning an abstract product B. Next we define another interface abstractProductA in which we define a method build that returns nothing, hence void. After that we create ourselves an interface abstractProductB in which we define a build method that returns nothing, also void. Now we create ourselves a new class called concreteFactory1 implementing abstract factory, which brings us to override two methods. The first is createProductA returning abstract product A, in which we return a new instance of createProductA1, and then a second method called createProductB returning an abstract product B, in which we return a new instance of concreteProductB1. After that we create another class, concreteFactory2, implementing abstract factory. This also brings us to implement two methods, first of which is createProductA, returning abstract product A, in which we return a new instance of concreteProductA2. The second method is createProductB, returning an abstract product B, in which we return a new instance of concreteProductB2. Now we are ready to create our first concrete product class, which we call concreteProductA1, implementing abstract product A, which brings us to implement a build method, returning void, in which we print the text building concrete product A1. Now we build another class, concrete product A2, implementing abstract product A, bringing us to implement the build method, returning nothing, in which we output the text, building concrete product A2. Now we create ourselves another class, concrete product B1, implementing abstract product B, which brings us to implement a build method, in which we output the text, building concrete product B1. Last but not least, we create ourselves a concrete product B2 class, implementing abstract product B, which brings us to implement the build method, returning void, in which we output the text, building concrete product B2. Now we are ready to build the main class. The first thing we do in the main method is creating the greeting message. And after that, we make a call to a new method, create products, in which we pass a new instance of concrete factory 1. After that, we repeat the same, but this time with concrete factory 2. Now let's build a create products method, taking an abstract factory as a parameter, and then creating an instance of abstract product A, in which we put the result of create product A. Next, we repeat the same for abstract product B, accessing the concrete factory and creating a product B class. Now we execute the build method of product A and product B. After that, we create ourselves a manifest.txt in which we tell Java what class to start. And now we need a script for building the application, starting with build.cmd for Windows. Here we start with @echo_off, and then we tell Java C to find every Java file and create a class file out of it. After that, we take jar to create ourselves the abstract factory demo.jar, in which we put the manifest.txt and every class file that we find. We also create ourselves a build file for Mac and Linux, which starts with bin bash. And the rest is very similar to the build.cmd file. We use Java C and jar to create the abstract factory demo.jar. Now we need two more scripts for running the application. The first one is for Windows. It's the run.cmd file, starting with @echo_off. And then we tell Java to run the abstract factory demo.jar file. For Mac and Linux, we create ourselves a run file, starting with bin bash. And the other call is like the one in the Windows file, java-jar abstract factory demo.jar. Now let's build and run the application. And let's take the main.java as a reference for the terminal output. What we see here is that we first make use of the concrete factory 1, creating ourselves a product A and product B. And after that, we make another call to create products, but this time with concrete factory 2. And then within concrete products, we create ourselves a product A2 and another product B2. Let's see how the abstract factory pattern looks in Python. The first thing that we create ourselves is the abstract factory class. Here we start by importing ABC and abstract method, because we want to make sure that this is an abstract class. Now we create the class abstract factory, which takes ABC as a parameter, and then we define an abstract method, create product A, and another abstract method, create product B. Next, we create an abstract product A class, which also starts by importing ABC and abstract method. Then we create the class abstract product A, which takes ABC as a parameter, and then we define an abstract method that we call build. After that, we create ourselves another class, abstract product B, in which we start by importing ABC, an abstract method, and then create the class abstract product B, which takes a parameter ABC, and then we define ourselves an abstract method called build. Now we create ourselves a concrete factory 1 class, starting by importing abstract factory, concrete product A1, as well as concrete product B1. Now we create a class concrete factory 1, which takes abstract factory as a parameter. This in turn brings us to implement create product A, in which we return a new instance concrete product A1. After that, we create a second method, concrete product B, in which we return a new instance of concrete product B1. Now we create ourselves another class, concrete factory 2, which imports abstract factory, concrete product A2, and concrete product B2. Now we create a class, concrete factory 2, which takes abstract factory as a parameter. This brings us to implement the concrete product A method, which returns a new instance of concrete product A2. We also need to implement the second method, create product B, which returns a new instance of concrete product B2. Now we create ourselves a concrete product A1 class. Here we start by importing abstract product A. Then we create the class concrete product A1, which takes abstract product A as a parameter. This brings us to implement a build method in which we output the text building concrete product A1. Now we create ourselves the concrete product A2 class, in which we start by importing abstract product A. Then we create the class concrete product A2, which takes abstract product A as a parameter, which in turn brings us to implement the build method, in which we output the text building concrete product A2. Now we create ourselves a concrete product B2 class, in which we import abstract product B. Then we create the class concreteProductB1, which takes abstractProductB as a parameter, which in turn brings us to implement the build class, in which we output the text building concreteProductB1. Last but not least, we create ourselves a concreteProductB2 class, starting by importing abstractProductB. Then we create the class concreteProductB2, in which we provide abstractProductB as a parameter, which in turn brings us to implement the build method, in which we output the text building concreteProductB2. Now let's create the main.py file. Here we start with importing concrete factory 1 and 2, and then we define ourselves a main method, in which we start by outputting the greeting message abstract factory pattern in Python. Then we make two calls to the new method createProducts, once for concrete factory 1 and then for concrete factory 2. Now let's define the method createProducts, which takes a factory as a parameter, and then we use the concrete factory to create ourselves a product A, which we save in product A, and then we repeat that for product B, which we save in product B. Now we make two calls for the build methods, once for product A and once for product B. Last but not least, we tell Python to execute the main method. Now we need two script files. The first one is run.cmd for Windows, starting with @echo_off, and then telling Python to run the main.py file. And then we define ourselves a second file named run, which we start by bin bash, and then telling Python 3 to run the main.py file. What we now need are execution rights for the Mac and Linux file run, which we provide by chmod +x and run. The only thing that remains now is running the application. Let's take the main.py file as a reference for the terminal output, in which we see that we are building two products A1 and B1 from the factory 1 class, and then again two products A2 and B2 from the factory 2 class. Alright, we've just discussed the abstract factory pattern in Java and Python. Have you encountered this pattern before, or is it entirely new to you? What did you find most interesting or valuable from learning about it? Let me know about your experience and drop a comment below. Want to try coding this yourself? The complete walkthrough and downloadable content are available on my website and on GitHub. Links are included in the video description below. So glad you're here for a visual journey through these ideas. Let your curiosity run wild and ask anything. And together let's dream up amazing things to explore next. Alright, we're through with the abstract factory pattern. Thank you very much for watching, and see you in the next video.